This video is going to show how to calculate the average atomic mass by using isotopic mixtures. You're going to calculate the atomic mass for each of the following elements, assuming that each consists of the isotopic mixture shown. So we're telling you what the percent of the mixture is, and here's the form we're going to use. The average atomic mass equals the percent times the mass plus the percent times the mass plus percent times the mass. So notice what we're doing. We're going to break each problem down into separate little problems. So example, naturally occurring iodine is 75.53% of the chlorine 35. And 35 is the mass number, which we know that is the weight of the atom. 24.47% chlorine 37. What is the average atomic mass for the chlorine, assuming 35 weighs 35 and Cl37 weighs 37? So what we're going to do is we're going to break this down into just two simple little problems. Here's the first problem right here. Here's the second problem right here. And we're going to add them together. And so according to our equation, it says take the percent times the mass. So we're going to take the percent times the mass. Then we're going to take the percent times the mass, and we're going to add them up. Okay? And so here's what they did. They took the percent. Since it's a percent, we have to change it to a regular number by dividing by 100. And that's what we did here. Divide it by 100. When you divide by 100, you just move it 2 decimal places backwards. And that's what we did there. And then we're going to multiply the two together, multiply two together, and then add those answers up. So let's work our problem. It's 99.985% hydrogen 1, 0.015% hydrogen 2. So what we're going to do is we're going to take our percent, we're going to make it two. Here's one problem here, and here's one problem here. We're breaking it up into two problems. We're going to add them together. So this becomes divide by 100, so move it 2 places backwards, or you can just use your calculator and divide it by 100, but that will give you 0.99985 times, and there's our mass number, 1. That's our first problem. Then we're going to move this 2 places, 1, 2, so it's going to be 0.0001500 times, I'm going to make those time signs so we can see that better, times 2. And what we're going to do is we're going to take those two answers, we add the two answers up, and that's going to give us our answer. So 0.99985 times 1 is going to be 0.99985. Add that to 0.0001500 times 2. And we multiply that in the calculator. Obviously this is going to become 15 times 2 is going to be 30, or 3 I guess you can say. So it's going to be 0.0003. And now we're going to take those two answers, we're going to add them up. So as we add them up, see 1, 2, 3. That becomes an 11, which makes that 9, 10, which makes the next 9, 10, which makes the next 9, 10. So we get 0.1.0001, and that's going to be grams per mole. So again, in summary, we just took each problem, we made it two simple little problems. I guess the hardest part really is how to convert these to percents, or to regular numbers, divide by 100. And that's going to be our answer.